Okay, so far in this unit you've learned how to solve linear equations and found zeros of linear functions. And now we want to solve inequalities. So when we have a less than sign or a greater than sign or a less than or equal to sign or a greater than or equal to sign. Now this will be very similar to solving linear equations. When you just need to add or subtract something from both sides, you can do that, no problem. That's what the addition principle says. Now, when we multiply, we have to be very careful. If we're multiplying or dividing both sides by a positive number, everything stays the same. The thing that changes is that if we're multiplying or dividing by a negative number, then we have to switch the inequality sign, okay? So that's what, that's what this reminds us of right here. So if you multiply or divide both sides of an inequality by a negative number, you have to reverse the inequality sign. Okay, so you're going to just switch which way it's facing. Okay, so this says solve and write the answer in both set notation and interval notation. Graph the answer. So the first thing we want to do is we want to get x on one side and everything else on one side. So let's go ahead here and add 6x to both sides so that we move it from the right hand side over to this left hand side. So here we'd have 1, and then here we'd have negative x plus 6x would be plus 5x is less than 12. Okay, now I'm going to subtract 1 from both sides. So I'd have 5x is less than 11. And finally, to get x by itself, I need to divide both sides by 5. So here I get x is less than 11 fifths. Now, for set notation, I'm just going to say x such that x is less than 11 fifths. So you're going to write what you just solved here, and you're just saying our variable here is x. Now let's go ahead and graph it before we write it in interval notation. So here's our number line. So 0, 1, 2, 3, 4. Here we could have negative 1. Okay, now we want less than 11 fifths. Now 11 fifths as a decimal, if you do that in your calculator, is 2.2. So if we want to graph that at 2.2, now since it's just a less than, not a less than or equal to, we'll put an open dot. So we're going to put an open dot at 2.2, and we want everything less than, meaning going toward negative infinity. Okay, so this blue line would be our graph. So I think interval notation is a little easier now that we have the graph. We see if we read from left to right, we've got negative infinity all the way up to 11 fifths. Okay, and since it was just a less than, we have the open dot, we're going to use a parenthesis. Okay, let's do another one. Here we've got 15 minus 4x is less than or equal to 13x minus 2. Okay, so the first thing, let's subtract 13x from both sides. Okay, so we'll get the x over on the left-hand side. So here we'll have 15, and then negative 4x minus 13x will give us a negative 17x. It's less than or equal to negative 2. Now I need to subtract 15 from both sides. So here I get negative 17x is less than or equal to negative 17. And finally, I need to divide both sides by negative 17. Now remember, we're dividing by a negative number, so we need to flip the sign. So this will be x is greater than or equal to 1. Okay, so that's our solution. Our set notation would just be x such that x is greater than or equal to 1. Okay, let's go ahead and make our graph. Okay, so we want greater than or equal to 1. So we're going to do 1 with a closed dot And then greater than or equal to, we're going to go toward the right, toward infinity. So that means our interval notation. Now since we're including 1, it's a closed dot, we're going to use a square bracket 1, comma, we're going up to infinity. Okay, let's do one more, and we're going to do this one because it has fractions, but you can use your calculator to help you add and subtract fractions if you want. Nothing changes. So the first thing I'm going to do here is subtract 4/3 x from both sides. So if you do negative 5/12 and subtract 4/3 in your calculator and hit math fraction to make it a fraction, you get negative 7/4 x is greater than or equal to 3/8. Now we would divide by negative 7/4. You can also multiply by the reciprocal, so negative 4/7, both sides. And so here the 4's cancel out, the 7's cancel out, the negatives cancel out. So we get x. We have to flip the sign since we're multiplying by a negative number. So it's less than or equal to. This would become 2 if we cancel out that 4. So we get negative 3/14. Okay, so our set notation will be x such that x is less than or equal to negative 3/14, which we know is between 0 and negative 1. So negative 3/14, and we're less than or equal to, so we're going to put a closed dot, and we're less than, so we're going to go to the left. So our interval notation will be from negative infinity up to negative 3/14. Since it's a closed dot, a less than or equal to, we're going to use a square bracket. Okay, so this was the beginning of solving linear inequalities.